Okay, so the question is, using integration, find the area of the region bounded by the triangle whose vertices are -1, 2, 1, 5 and 3, 4. Okay, so if three vertices are given to you, we could have used one direct formula of determinant, right, which we already know to find the area of the triangle. But since it is specifically mentioned that I need to find the area using integration, right, if this is the requirement, then we will have to proceed using the concept of area bounded by the region, and in this case I will need the equations of the sides of the triangle, right? So for that, first let us try to draw the figure here. So on a graph paper, this figure will look like this. Okay, this point is 1, 5, then this another point becomes 3, 4, and the leftmost point is -1, 2, right? So after joining these points, I will get these three lines. I am considering my points as A, B and C, right? Now let us first of all find the equations of the lines. Let us call this first line L1, this second line L2, maybe this should be L2, and this as our L3 line. Okay, so using 2-point form, I am writing the equation of AB, which is my line 1. So for that I am using 1, 5 and -1, 2 as my coordinates. So my equation will become y minus 2 is equal to 5 minus 2 upon 1 minus -1 into x minus -1, which is x plus 1. From here I get equation 1 of line 1, which is given by 3x minus 2y plus 7 equal to 0. This is the equation of line 1. Similarly, let us try to calculate the equation of line 2, right? In this case, when you proceed in a similar manner, you will get equation of line as x plus 2y minus 11 equal to 0. And similarly, you will get equation of line 3. Equation of line 3 will be x minus 2y plus 5 equal to 0. So we have these three equations with us now, using 2-point form as we did for the first line, right? Further, if we have to solve this question using integration, it would be best if we could express each line as y is equal to something, right? So I am doing the same thing. I am representing my first line as y is equal to 3x plus 7 upon 2. Second line can be written as y is equal to 11 minus x upon 2, and similarly the third line can be written as y is equal to x plus 5 upon 2. Now why we have done this? Because if I consider now first line as y is equal to fx, second line as y is equal to gx, and third line as y is equal to hx, then I very well know what happens if my first curve fx is completely above my second curve gx, right? Now this thing happens in the region which is after B. Before B, your curve is actually hx. Okay, so if I have to calculate this portion which I am shading right now, so now this can be directly found by doing this particular integration of fx minus hx from -1 to 1, right? We are going from -1 to 1 and calculating fx minus hx. Now when we move further, our function, above function, is now equation of line 2, which is basically gx, right? So now to get this second area, I will do this particular integration. I will integrate gx minus again hx, because hx is the lower function, dx, and this I will do from plus 1 up to 3, right? Plus 1 up to 3. This integration will give me my final result. So we just have to substitute the values of fx, gx and hx in this integral to get the required area. So now this solution is very easy. This will give us simple equations like these. Let us try to write everything. So we will get two different integrals. The first integral is from -1 to 1, and the quantities inside will be 3x plus 7 upon 2 minus x plus 5 upon 2 this dx, and then second integral is plus integral of 1 to 2 11 minus x upon 2 minus x plus 5 upon 2. Now I have done nothing till now. I have just substituted the values of fx, hx and gx, hx, which we have already seen, right? Okay, so if we proceed in this manner, now the integration of linear function is very easy. So let us just simplify the quantities first. On simplification, we will get integral from -1 to 1, and inside on simplification will be just x plus 1, and the second integral will be from 1 to 3, if I am not wrong. Let me just check. 1 to 3, yes, right. So let us change this here also. So it is integral from 1 to 3, and on simplification this value becomes 3 minus x dx, right? So let us simplify this. On integration it will become how much? It will become x square upon 2 plus x when integral is from -1 to 1, and your second integral is 3x minus x square upon 2 when integral goes from 1 to 3, right? So this on substitution of limits will give you your answer, which is equal to 4 square units. This is the area bounded by the triangle.